Okay, so then if we don't need to check our solutions when we have a square in the equation, when do we need to check them? And one situation is when we have a square root. Because in order to solve an equation that has a square root in it, what we do is we isolate the root on one side of the equation and then we square both sides. The logic here is if two things are equal, then their squares will be equal. So this is a statement that goes this way. If these are equal, then when I square them, they're still going to be equal. The problem is that we don't know whether or not these two things are equal yet. We're trying to show that there is an x that can make them equal. So if you look over here, you can see exactly what I'm talking about. Here, if the x that we were working with happened to make one side -2 and the other side 2, then they wouldn't be equal. But you'll notice that after we square them, they are going to be equal. So this is one of these things where we can't reverse the thing. We can't say because they're equal here after being squared, it means they were equal before. This doesn't work. So this is the kind of situation that that basically, even if we're doing the algebra completely correctly, can lead to a wrong solution. So it's not a big deal though. All we have to do is just check our solutions. So when we square an entire side of the equation and then find the values that make that equal, they may or may not make the original thing equal. They might make one side negative and the other side positive. So let's just go ahead and do that. We're squaring the square root. That makes it go away. And on this side we have x squared. So again, just like in the previous video, we've got a equation with a square in it, so let's use principle of zeros. So I'm going to subtract x from both sides and add 2 to both sides, which is going to give me this right here. Completely reversible process, so if this is equal, this will be equal. Now I'm just going to rewrite this in another format. How about x minus 2, x plus, this seems wrong, sorry, this is supposed to be a plus in here. Okay. So that makes this a minus, and now we can factor this, okay? Otherwise we have to go to the quadratic formula. I don't want to do that right now. So we're going to factor this like this, and then that is going to lead us via the principle of zeros to two possibilities. Either the first factor is 0, or the second factor is 0, which leads us to two solutions, either x is 2 or x is minus 1. So because of the problem of not being able to reverse this step, just because everything is equal after squaring doesn't mean it works prior to squaring, so I'm going to have to take these back and check in original. So let's just do that right over here. So let's put in that -1. The square root of -1 plus 2 is equal to -1. The square root of 1 is equal to -1. The square root of 1 is 1. And that is not equal to -1. So that's exactly the problem. Even though this value makes these things equal after we square it, it doesn't make them equal before we square it. So this is not a solution. Now let's take the 2 and try it. So then we get the square root of 2 plus 2 is equal to 2. The square root of 4 is equal to 2. Yes, so this one works.